Hello everyone, my name is Boqian. Today I'm gonna give you a brief introduction to the Falcon project. I will also give you a general idea about how to set up a storage miner, as well as the hardware requirement for building up such a cluster. To begin with, here is the question: what is Filecoin? Well, Filecoin is a peer-to-peer network that stores files on the internet, with built-in economic incentives to ensure files are stored reliably over time. In Filecoin, available storage, the price of that storage is not controlled by any single company or institution. Instead, Filecoin facilitates open markets for storing and retrieving files that anyone can participate in. For example, users pay to store their files on storage miners, and the storage miners are the computers responsible for storing files and proving they have stored the files correctly over time. Anyone who wants to store their files or get paid for storing other users' files can join Filecoin. So today, I will talk about how to join Filecoin as a storage miner, which will get paid for storing other users' files. And before that, let's get familiar with some basic concepts of Filecoin first. The first one is the network. Like other cryptocurrencies, there is a network, and the Falcon network is a distributed peer-to-peer network formed by Falcon peers who participate in different ways. Peers communicate over secure channels that they use to distribute information to the network, to transfer data among themselves, and to discover other peers, maintaining a well-connected swarm in which information like blocks and messages flows swiftly even when many thousands of peers participate. And then the Filecoin nodes. The Filecoin nodes, also called the Filecoin clients, are the peers that sync the Filecoin blockchain and validate the message in every block, which once applied provide a global state. Whether you are a user who wants to upload data to the Falcon network or a storage miner who wants to store other users' files, you have to run a Falcon node. Nodes can propose storage and retrieval deals to Falcon miners and pay for them as they executed. So there are several Falcon node implementations in the works, and the Lotus is the most used one and the most advanced one. So today, when I talk about the Falcon nodes, I will be talking about Lotus node. And then it's the Falcon miners, which is today's topic. The miners provide services to the network by executing different types of deals and appending new blocks to the chain every 30 seconds, for which they can collect file rewards. And the file tokens are the incentives for the Filecoin network. Like Lotus, the Lotus miner is the most advanced and used one for Filecoin miner to this day. So today, when I talk about Filecoin miners, I'll be talking about Lotus miner. And the deals are the core function of the Filecoin network and represent an agreement made between a client and a miner for a storage contract. There are two types of deals: storage deals and retrieval deals. Storage deals are agreements between the client and miners to store some data in the Filecoin network. On the opposite, the retrieval deals are the agreements between clients and miner to extract data that is stored in the Filecoin network. So now, let's talk about how to become a storage miner so that you can get paid for storing other users' files. First of all, as I mentioned earlier, you need a Lotus node to sync with the Filecoin network and to manage your Filecoin wallets. Then you need a Lotus miner to deal with the storage deals and retrieval deals. Also, Lotus miner is responsible for proving that the files you stored in is correct over time, and to make sure that the client's files are always good and retrievable. Next, you also need a workers. Storing data on the Falcon network is probably more complicated than you think. We call the storing data on the Filecoin this process a sealing process, and there are several phases during the whole process. and each phase needs different types of resources. So I will explain these phases later. So the Lotus node, Lotus miner, and sealing workers are the three must-have components to run a storage miner. And the architecture could be very flexible. For example, you can run all these processes in a single machine, or you can run different processes in different machines. For example, one for Lotus node, one for Lotus miner, and one for sealing worker. You can even split the sealing processes into the different phases and run them on different sealing workers. So basically, it depends on what resources do you have. And for the last component, the storage server is optional. You can choose to store data on a dedicated storage server, or you can just store data on a Lotus node or Lotus miner machine. However, it is strongly recommended to use the storage servers or any other kind of reliable storage system because you should make sure that the files you store won't get lost or get corrupted over time. Otherwise, you will be punished. And also, the more data you store, the more file you will be paid. So, a storage server or a storage cluster will be a great choice. Then I will talk about the minimum hardware requirements for each component. Lotus Node works as keeping wallets and interfacing with the network. And the minimum requirement to run a Lotus node is 2 to 4 CPU cores, 80 GB of memories. As the size of data store of the Lotus node could get really fast, I strongly recommend to use at least 1 terabyte storage to avoid re-importing the node constantly. And of course, the Lotus node should have a great network condition so it can communicate with other peers. And for Lotus Miner, you need a 8 or more core CPU, and also a NVIDIA GPU is required to prove and win blocks. Here is a list of NVIDIA GPU that is officially supported by Lotus Miner and Lotus Worker. Then you will need at least 128 GB of memory. With that, you also need a 256 GB of swap on a very fast NVMe SSD storage medium. And finally, you need at least 2 TB disk space if you don't split the market node from your Lotus miner, because there will be 10 files taking up a large amount of space when you receive storage deals from clients. And for sealing workers, storage miners have to perform operations of different nature, which differ in how they use CPU and GPU resources. And these different operations could be divided into 4 phases: the pre-commit phase 1, pre-commit phase 2, commit phase 1, and commit phase 2. And I will explain these 4 phases one by one. The first one is sealing pre-commit phase 1. In this phase, the proof of replication (SDR) encoding takes place. The pre-commit phase 1 is a CPU-bound single-threaded phase, which means that you only use 1 core of CPU to do the job. And this phase is expected to take an order of several hours. The protocol labs found that AMD processes with SHA extensions accelerate this process to a considerable degree. And also using CPU with higher clock rates will also improve the performance. So in conclusion, pre-commit phase 1 relies on the CPU with high clock rates, especially AMD processors with SHA extensions. And since pre-commit phase 1 is single-threaded, you can run multiple pre-commit phase 1 jobs at the same time on a single worker machine. If your memory, and threads are sufficient. Then the pre-commit phase 2. In this phase, Merkle tree generation is performed, and this process is primarily GPU bound. You can also use a CPU to do the job, but it will take much longer time. So use CPU to do the job is not a good idea, apparently. When you're deploying a GPU, this phase is expected to take on the order of 45 minutes to an hour. The time varies based on the type of GPU and the version of Lotus you are using. I've heard for the latest version of latest release of Lotus, they did a much improvement on the seeding process. And then the seeding commit phase 1. This is an intermediate phase that performs preparation necessary to generate a proof. It is CPU bound and typically complete in tens of seconds, so it hardly uses any memory resources. And the last phase is commit phase 2. This phase involves the creation of a snark, which is used to compress the requisite proof before it is broadcast to the blockchain. It is a GPU-intensive process that is expected to take on the order of 20 to 30 minutes to complete. And also, the time varies based on the GPU you are using, and also the version of the Lotus release. Here is a chart showing how the phases use CPU, GPU, and memory resources. For the single seeding pre-commit phase 1, it uses only CPU resources, no GPU and memory. It only uses 1 core of CPU per job, and the memory could use 128 gigabyte. But in my experience, a single PC1 job would use at most 70 gigabyte of memory. And the pre-commit phase 2 use both GPU and CPU resources and also memory. And also in my experience, a single pre-commit phase 2 job will use at most 50 gigabyte of memory if you are using a GPU. And seeding commit phase 1 use all cores of CPU and hardly use any memory resources. And commit phase 2 use both CPU and GPU, and it could use at most 192 gigabyte of memory. So don't use CPU on the commit phase 2 job. It may never end. It will never end. And here is 2 example architectures provided by Protocol Labs. The first one is an AMD-based architecture. The Lotus node and Lotus miner are running on the same machine. There is one machine without GPU to do pre-commit phase 1 job, and another machine with 2 GPU to do the other phases of jobs. For example, the pre-commit phase 1, commit phase 1, and commit phase 2. There are 2 GPU, and apparently one is for PC2 and one is for C1 or C2. The second one is exactly the same architecture, but use the Intel machines instead. Also, one machine for miner and Lotus node, one machine for PC1 jobs only, and another machine with 2 GPU for the other jobs. Yeah. There is not enough time to show you how to build and install every components of the Filecoin project step by step. So I have attached several useful links from the official tutorials. For example, install and set up the Lotus node, the high performance miner node, one or several Lotus workers. There's an article telling you how to split the market node from the miner process so that the storage miner, storage deals and the storage retrieval deals will not affect your miner to prove or win blocks. And there's another one you might be interested that telling you what types of rewards miners could earn from contributing to the Filecoin network. Yeah, that is pretty much what I'm gonna to share today. Thank you.